RPA and Beyond. Welcome everyone to this session titled RPA and Beyond, part of the Digital Transformation and Industry 4.0 Masterclass by Advanced Innovation Group. In this module, we'll explore robotic process automation and its evolving landscape. We'll also touch upon complementary technologies such as cloud, blockchain, and 3D printing, understanding how they interconnect and power modern digital enterprises. Robotic process automation. Let's begin with robotic process automation, RPA. RPA is a software-driven automation approach where bots perform high-volume, repetitive, rule-based tasks. These bots behave like human users. They log in using credentials, access applications like ERP or email, execute tasks such as data entry or document generation, and log out. The goal is to reduce manual effort, improve accuracy, and free up human talent for higher-value work. Example of RPA process. Here's a visual flow of an RPA process. It typically starts with a trigger, such as an incoming email or a scheduled job. Then the bot picks up data, processes it through a business logic engine, and updates one or more systems. For example, a bot can read invoices from emails, extract details, validate against PO data in SAP, and generate accounting entries, all without human intervention. Common traits of RPA-compatible processes. Let's identify what makes a process suitable for RPA. 1. Highly transactional. Processes with frequent high-volume transactions. 2. Time-consuming. Manual, repetitive steps that drain resources. 3. Highly scalable. Can experience volume surges like payroll during month-end. 4. Low complexity. Rule-based logic with minimal exceptions. 5. Highly standardized. Minimal process variation and clear inputs, outputs. If a process ticks at least 3 of these boxes, it's a great candidate for RPA. Use cases and applications by function. RPA use cases span across functions. Finance, automating accounts payable, reconciliations, report generation. IT, handling routine software installation, testing, monitoring, and reporting. Call centers, customer onboarding, service ticket routing and reporting. Supply chain, procurement automation, supplier data management, R2P flows. HR, onboarding, payroll validation, employee master data maintenance. These applications improve speed, reduce cost, and ensure consistency across enterprise processes. Cloud storage. Definition. Cloud storage refers to on-demand access to computing resources via the Internet. It can be public, private, or hybrid. Cloud storage is the foundation for scalability and flexibility. Businesses now store documents, run applications, and even build AI models on the cloud. It enables real-time collaboration, anywhere, anytime access, and resilient backups, replacing traditional on-premise systems. Here we compare on-prem versus cloud models in terms of total cost of ownership, TCO. While on-prem may seem cheaper initially, cloud offers long-term savings through pay-per-use, elastic capacity, automatic updates, and lower maintenance overhead. Cloud also enables agile deployment of services, a key enabler for digital transformation. Blockchain. Definition. Blockchain is a decentralized digital ledger. Instead of storing records in a central database, data is stored in blocks, distributed across a network. Each transaction is verified via consensus and becomes immutable once added. The result is tamper-proof, auditable, and transparent data, ideal for trust-sensitive industries like finance, healthcare, and supply chains. Blockchain key use cases. Blockchain applications include 1. Storing digital records, medical records, legal contracts, academic certificates. 2. Exchanging digital assets, cryptocurrencies, tokenized securities, loyalty points. 3. Smart contracts, auto-executing agreements with embedded logic. This removes intermediaries, reduces fraud, and improves transparency. For example, a smart contract in insurance can release payment as soon as all conditions are digitally verified. Let's explore how blockchain is used across sectors. Financial services, faster international payments, trade finance, AML compliance. Healthcare, secure clinical data sharing and claim settlement automation. Public sector, digital identity systems, transparent voting, land registry. Consumer goods, product traceability, warranty validation, loyalty management. Energy, blockchain-based peer-to-peer energy trading. These are real-world innovations solving old problems in new ways. Additive manufacturing, 3D printing. Additive manufacturing, or 3D printing, involves building objects layer by layer. It enables on-demand production, custom designs, and geographical flexibility. This is a game-changer for industries like aerospace, healthcare, and automotive, especially for making spare parts, custom tools, and rapid prototypes. 3D printing, use cases. Key applications include product ideation, quickly create and test concepts. Tooling, design custom jigs, molds, or testing fixtures. Production, execute small batch runs and distributed manufacturing. Spare parts, print legacy or low-volume parts on demand, reducing inventory costs. This technology drastically shortens development time and brings agility to engineering and production. Let's summarize the key technologies shaping Industry 4.0, all centered around data as the core enabler. Starting with data generation and sharing, technologies like Internet of Things, IoT, collect real-time data through connected devices. Wearables and smart sensors track physical environments and user behavior. Virtual and augmented reality provide immersive training and operational support. Moving to data analysis and action. Big data analytics helps extract meaningful patterns from huge datasets. Artificial intelligence, AI, and machine learning, ML, allow systems to learn and improve over time. Autonomous robots use this intelligence to perform tasks independently. Finally, data security and storage is ensured through cloud storage, which enables scalable access to data, and blockchain, offering secure, tamper-proof data sharing. Together, these technologies drive smarter decisions, increased automation, and enhanced productivity across industries. IoT, cloud, and AI dominate in scale. This slide highlights the current and projected global market size of various emerging technologies, measured in billion USD from 2019 to 2023. The overall market grew at a 15% compound annual growth rate, CAGR, a strong indicator of rapid technological adoption and investment. Looking at the bar chart, in 2019, the market size of IoT was around 720 billion USD, which increased significantly to 1,100 billion USD by 2023, making it the largest among all technologies. Cloud computing also saw major growth, rising from 229 billion to 500 billion US dollars. AI grew from 38 billion to 98 billion US dollars in the same period. Other technologies such as additive manufacturing, AM, AR/VR, RPA, and blockchain showed growth too, but at a much smaller scale. Now looking at the comparison chart on the right. Taking blockchain and RPA as the base, 1x, AR/VR is around 4x, AM is 5x, AI jumps to approximately 15x, cloud scales up to 80x, and IoT leads with a massive approximately 250x. In summary, the technologies dominating the market in terms of scale and projected growth, are IoT, cloud, and AI. These are the key areas businesses and investors should focus on, as they are expected to lead technological transformation globally.